Give you guys enough time to get started on your guys' work. Looking at this type of problem, we want to be able to identify and graph our set depending on whether we have greater than or less than, and be able to factor these. So what I want to be able to do here is I'm going to go ahead and subtract out a 1 from both sides, because that's the first thing I want to be able to do, is bring everything over to my left-hand side. This is not my regular tablet, so I apologize. So I have that value there. I'm going to go ahead and just erase a little bit on this top side right here, just so I can factor. Factor my terms. We're going to get -2 on top by multiplying our a and c. 2 x's are going to be here for our advanced snowflake method. And then our bottom portion will be our b, which is 1. What multiplies to give you -2 but adds up to give you -1 would be 2 and -1. Perfect. I'm going to go ahead and write these out. In this case, my left-hand side can be reduced to x plus 1. On the other side, we're going to get 2x minus 1 is greater than or equal to 0. With our solutions being x is equal to -1 and 1/2. Okay. I'll always give you good numbers when I'm asking you guys to do it on the quiz, so they're not going to give you any values that are going to be kind of wacky or wompy. I'll always give you values that will be giving you good points. With this one here, I'm going to kind of go ahead and graph this by doing this on the top here so people in the back can see it as well. On my box here, we're going to look at doing a number line first, and then we'll write my inequality. So my interval for this, let's look at just a number there. Let's look, changing it up, let's do 0. We have it at -1 and 1/2. So I'm just kind of making that my step there. Are open or closed? Closed. Closed. Inequality is solid. So I'm going to go closed circle. Closed circle. Are they connected or not connected? Not connected. So we're going to go away from our number line. Okay. O is when it's greater than or equal to, we're going to have it going away. That means we're going to have 2 intervals we're going to look at. The first one being -infinity to -1. And 1/2 to what? Yes. Oh, brackets, yes. At least for this side. Let me get good thinking. Let me bring that down a little bit. Oh, I don't want that. Try to write this again. Yes, brackets indeed. Bracket here, bracket here. Infinity, we don't use brackets, right? We use it open circle. So that would be my solution for that. You'll definitely have something like this on your guys' test. So that's why I'm kind of revisiting and going back and looking at this material. The one to the right, we want to be able to kind of solve this one again. It's solving out just as well. We want to be able to solve a quadratic. Usually we're going to be able to solve this by using factoring. If we can't factor it, use completing the square. If we can't complete the square, use quadratic equations. But majority of the time will probably always be factor. I'm going to bring over my left-hand side, my 2x. So I'm going to bring this to the left-hand side. This will just give me x squared. I'm going to kind of solve this out a little faster. My -3x will be brought down. And then I'm going to subtract out 4x to this side and bring it over. -4x, or -4 is less than 0. We want to be able to factor that. I'll factor that again if I need to as well. What multiplies to give us -4 but adds up to give us -3? -4 and 1. Okay. Our two factors will be x minus 4. And again, my apologies for this bad handwriting. This is not my usual tablet. That looks horrible. Horrible. Our writing's already bad as it is, let alone writing this out. Okay. We're going to get our solutions as x is equal to 4 and -1. So it's going to kind of help us out graph this. We have the inequality, or let's see the number line again. Our number line is going to be drawn first. It's easier to graph on that. The first one being, we're going to have 0 here, -1, 1, 2, 3, and 4. Do we have open or closed circles? Open. So I'm going to go ahead and draw that with open. Why is it just open though? It's less than, right, but no line underneath it, so we leave it as open. Is it open or closed? I'm sorry, open or closed. Is it connected or not connected? Connected. Our connecting on our line will be here. Okay. We want to be able to actually write out the inequality for this, our interval notation. And this is going to go to, I'm sorry, I should have put 4 here. Our interval notation for this will be open bracket -4, comma, open bracket 4. So 2 separate ways you can write this. We're going to look at this again when we do inequalities and absolute values. It's going to come into play again. So it's pretty straightforward, just solving them out. It's pretty straightforward, so don't freak out about that. But that's what we have. So go ahead and pull out that handout for me. The other one, I think it's a white paper, should have like 3 cylinders up on top, word problems. Again, I wanted to revisit word problems. I wanted to reteach you it, guys, because I feel like I did a bad job on it, so my apologies. I figured this is going to go better on it. I was looking over the test. The test itself has several problems. Word problems. The first part that you guys want to be able to identify is read the problem carefully more than once if we need to. This is kind of crucial. I know it's kind of like duh, but it's just the more you read it, the better you understand it. Diagrams help out if you can do it that way. Being able to clearly identify. This is the same ones that we're doing. The other pre-calculus classes are doing distance and rate times. More complex type of problems are doing perimeters and areas, principal and interest. But we're just going to cover mixture because I feel like we're not going to really see it again. And I'd rather just do a better job on teaching you guys just one thing and to just identify the types of word problems we're going to see. So we're just going to look at focusing on different types of word problems. The 3 different types that we are going to use for mixtures in this case will be the same kind of setups for all of them, but just different types of things. So one will be chemical or chemical solution, or mixture solutions, solutions of sugars and waters and alcohol. The other one will be of alloys, so nickel and nickel alloys, which is the same setup, and then fruit juices, mixing 100% concentrated grape juice with 25% fruit juice type of thing. But the setup is essentially the same thing. So, yeah. Second thing that we want to be able to see here is identify the variable. Identifying the variables is going to be very key and important. In this case, it's always going to be our solution number 1. Solution number 1 will be our variable x, and then how that relates to the other 2, I'll show you guys how that looks. And we're going to do all 6 with these. I'm going to give you the equation for the first 2. The next 2 we're actually going to solve out together, and then the last one I'm going to ask you guys to solve those out. So we only have 6 problems. By the 6th problem, we should be good. I'm trying to just give you guys a better understanding of this because I feel like I didn't do a good job. The third one of this is draw and diagram. So in this case, I've given you guys little cylinders on your guys' paper. It helps you to identify those a little bit clearer. You can create boxes just as we had before. You can make little cylinder boxes if you need to. Tables are always helpful if you guys need them. In this case, because we're just doing mixture problems, the cylinder problems will probably be easiest. Set up an equation. We're going to set up the equation by multiplying our percentages by how much we're needing of each concentration. I'll show you guys what that looks like. And then the last one would be to solve the problem and check our answers. We want to be able to see if it's relatively safe within our reasoning to write it out. And there's going to be we're going to look at 2 different types of ways we're going to see the type of problems. And I'm going to try to hopefully identify it and clearly identify it for you guys. So spent like an hour on this lesson plan for only 6 slides, but I feel like cutting out the verbiage on it and making it more clear for you will help you guys out. Because I want you guys to do well. I really want you guys to do well in this class. Okay. So I'm sorry we have to stop here, go back, and then go back to inequalities, but I feel like inequalities, some of you guys are picking this up really fast. And I've taught it before, so it's kind of easy. Okay. So those are 5 things. Really read it carefully, really break it down into each part and to kind of, ask yourself questions about it. What is it really asking us for, that kind of thing. The next part of this will be the following: mixture problems. They're always going to look at, we're mixing 2 mixtures to have a final solution. A nickel alloy of 24% and another nickel alloy of concentration of 15% needs to be mixtured into a new percentage. Brand A and brand B are going to give you your final solution. So we're going to be able to see that we're adding 2 things to give us a final product. The biggest key things on these is identifying and determining the missing values. What is our missing value? What are we trying to solve out for? And determine the missing solution by the material that's given. Okay, and there's going to be 2 different ways we want to see it. So I'm hoping you guys can identify those. In our blue type of situation, we're going to be given a first solution. We're going to be given our final solution. So we're going to have to subtract to find the missing second equation. And I'll show you what I mean by that. Okay. Find the missing solution means that we have to subtract the missing of the second solution in our final. If we're given 2 parts of our solution to find the final, we want to be using addition. And again, I'm going to show you what I mean by that, but if you want to highlight anything in your notes, it'd be those 2 parts of it. Those are going to be very, very key when doing these type of problems. Is what are you given? Are you given 1 part of the solution and the final product? Or are you given 2 parts of the solution to find your final mixture? And I'll kind of explain that to you when we kind of jump into problems. And that's the easiest way to do these. Okay. In our solutions, we're going to be looking at a percentage and amount. God, I hate this writing. Percentage and amount. And percentage and amount. But these are the clearest, this is important for us. And that's what we want to be able to reference in a lot of these. Is the first 2 parts I think are easy to find out. The solution number 1 will always be our x. It's being able to determine the remaining part of it. And I'm going to show you what I mean by that. And really just trying to break it down to help you guys understand. The solving part, I'll show you guys how to do. Again, I'm just going to give you the answers for the first 2 because I want to show you guys a setup. But after that, I'll show you guys how to work out the last 4 if I need to. And then I'll give you guys your homework for you guys to work on and really try out. The reason why I think we're having difficulty is the other one was telling us a pure concentration was added already. It changes up the problem if you already have poured something into a solution. And it changes up what you're asking for a final. So in that case, we're not going to do that. Okay. But I will get you guys the correct lingo for it. Okay. Can we move on? Are we okay? So let's just jump into this. And I know it's kind of weird for us to do that, but I think the best way to kind of do that is this. So we're going to look at 2 different types of ways of seeing the problem. And I'm going to write up the equations in the boxes up above. You guys have a little bit of the area. If you need to write it somewhere else on the side, please do so. First thing it tells us is to read the problem. It says, James wants to make a 15-ounce solution, a 15 fluid ounce of 20% sugar solution by mixing together 10% of one, 60% of another. How much of each solution must he use? So, just off the get-go, just to clear this up, the first solution you're always going to have is x. We always got to be able to determine an x value. So, in each one of these boxes, if this is going to help you out to set it up, you're always going to be given one x value. We need to be able to determine that out. That's already done. So x is the amount we need for each one of those. So in each one of those boxes, I don't care, x will always be that first one. Okay. The second thing we want to be able to identify and read is what James is making. So we're making a 15 fluid ounce solution of 20%. So this is our final product. He says we want to make it. So that's the final. So that let's put that information in. It's 15 ounces down below at 20% concentration. Okay. Now, stopping here, what are we given already? We're given, we already want to find solution number one, and we already have a final solution, right? So this is a part that you want to automatically tell yourself is, what are you looking for to solving? So looking at that box that we had right up above, are we going to add or subtract them? It says subtract. So in this case, I'm just going to put subtract. Without doing really anything yet, this is the key part of that. This is subtraction. Because, look at what it gives us. I want to be able to put in everything that I need to. Solution number one, it is already going to be an x variable. That's already given to us. We already know it's always going to have to be there. Okay. The next part of that is just being able to read the problem and write everything in. It tells us in the get-go, James wants to make a 15 fluid ounce solution at 20%. That's what he wants to make. So that's what we're already given. Okay? The rest of the part we'll kind of fill in as we go. But in this case, we're looking at writing this bottom portion to it. So we're given a solution one, and we're given a final solution. So we're given a part one solution, we're given the final solution, so we need to be able to find the second one. It tells us if we're given the one solution and a final, it tells us to use subtraction. And that's the key thing of this, is we want to be able to use subtraction. And I'll come back and look at this, so don't freak out, okay? The next part, it tells us by mixing together, so we want to be able to find the percentages of these. By mixing 10% of one, whatever that happens to be, so we can put that in our first box, and 60% of the other. Okay? So we're just missing the second part of that equation. We're missing this bottom portion of this equation. Now, because we know that we identified it to be our solution one and our final solution, and we're looking at subtraction, the way that we want to be able to identify that is by the x and 15. Okay? To write that final equation as using subtraction, that final equation will be 15 minus x. Take your whatever value it's given on the bottom portions of those and subtract them. Take your whole number minus x. If it would be the addition portion, we'll do, it would have been 15 plus x. Right? And I'll show you what I mean in this other problem. I think that's half your battle being able to set it up. I think the solving portion we should be able to do. So, writing this up above, we want to be able to write out the equation that's going to help us solve this. So, converting our percentages into decimals. So, 0.10 times x, which is one solution, plus 60% or 0.6 times our second solution, 15 minus x, is going to be equal to 0.20 times 15. And again, I'm not going to show you guys how to solve these ones out yet because I'd rather get into the other one before we solve it out. So I'm going to give you guys the answer for this. I love the fact that my TI-89 can do this, but I'll solve this one out for you. All it is using distributive property and combining like terms to get your final solution. Plus 0.60. If you want to just work this out, you're more than welcome to. I'll give you guys the answer for this as well. In this case, my x is going to be equal to 12. Okay.
Why do you put 15 in front of that?
It's just do it for me for that, because if we do it the other way, 15. The reason why 15, it has to be 15 minus x, not negative x minus 15. When you look at it this way, you want to be able to think about what it's asking for. Our final solution has a total amount of how much? 15. If you use x minus 15, that means the number that we're putting in is greater than 15 units. So the reason why this has to be 15 minus x is the difference of this will be the remaining of this. Does that make sense? We're looking at the total amount, subtracting our last will be the remaining. So let's say our first solution was 10. If I plug in 10 in here, it's going to be 5. 5 and 10 is going to give me 15. So we're looking at just the amount that we can create with this. And this is why it's kind of backwards and not x minus 15 for it. So just think of it as your whole number minus your value. Okay. And we're going to do the same thing if we're going to be adding. We're going to put our whole number plus x. It doesn't make any difference, but it's easier to see it this way than the other way around. Okay. So we're looking at a concentration of 15. Again, our solution will be 12 fluid ounces. If the other one plugged in, we'd get 3 fluid ounces, which would be adding up to that 15, which kind of makes sense. Okay. In our other verse, in our other problem over here, again, our x will always be our first solution. It will always give you something of that value. So x is already there for you. We just want to be able to fill in either solution number 2 or the final solution. Okay. So Mary wants to make a 24% sugar solution. So it tells us the final concentration of that percentage is how much? 24%. So let's just put that over on the final solution part. So we can definitely do that. And that takes up our first one right here, 24%. She wants to make that. Good. She already poured 10 fluid ounces at how much? So she's telling us already that she already has one part that is 10 ounce or 2% of 10 ounces. Okay. How many fluid ounces of a 44%, so we need to put that last 44 in here, to get our desired mixture? Okay. So this is going back to looking at that box again. Okay, we just filled in our information. 44% solution, how much do we need of it? It's already telling us that she has a 2% solution at 10, 10 fluid ounces to make our final solution. How much of the final one we're trying to make? So this is, we're missing this bottom equation of it. What are we given so far? What are we trying to look for? It gives us a solution of 1, and it gives us a solution of 2. What does it say to do if we're given 2 solutions? Look at your paper. Look at your paper. Not 10 minus x. Not 10 minus x. 10 plus x. Because look at it. We're given, we want to be able to make this final part to it. So we're looking at linking the final solution. It tells us it's giving us the second solution, and it's giving us the first solution.
Oh, okay.
Right? So we're trying to find this missing portion down here to kind of write out our equation. So we're given solution 1 and solution 2, which is the second part of it. If you're given 2 solutions, it's asking you to use addition. Right? In the case that we had before, we weren't given this part. We were given the final solution, and we're given one part of it. So if you're given one part in the final, use subtraction. If we're given both of the first parts, we want to use addition. So in the final addition part, it's still using that bottom portion. It's still using the x and 10. So I'm going to write it out as 10 plus x. Yes?
So I'm still kind of lost. How do you determine if you have both solutions?
Read the context of the problem. Read the context of the problem. I know it kind of sounds weird. You just got to be able to write it out and read it and read it and read it. It's kind of one of those things you just got to look for it. And the first one I'm saying here, the reason why I can look at this and identify it is because James wants to make this solution. He's already been given the final solution to this. So I wrote 20% at 15 ounces. Okay, so I have that already to begin with. Sugar solution by mixing together, he wants to mix together two different things. In this case, 10%, which we know X is to be the first one, is here. So we're automatically given these two parts of these.
What about the 60%?
And so we can fill that in later, or we can fill that in as we go. And a 60% sugar solution, so we're given the 16%. Does it tell us how many fluid ounces it is? No. Does it tell us anything besides 60%? No.
You need to do the first one.
It did just like the first one. It tells us the first one at 10% because we know that happens to always be X. We'll always know this first concentration to be X. So in every one of those little equations, you can put X on that first solution. Always, it will always be there. Yes?
Does it matter if we flip-flop solution 1 and 2?
No, it doesn't matter. It doesn't matter. I'm just going to go by the same kind of thing, no, it doesn't matter. If you can read the question out and this already makes sense to you, by all means. Solution number 1 and solution number 2 are interessential because commutative property still holds it the same way. But in this case, I'm always going to use this as my first solution as the X variable of what we need to add to it, right? So again, because I'm given, looking at the solutions for the second one, so looking at how we want to write this out, it tells us she wants to make a 24% sugar solution. Do we give any other information besides that? No, so that's why I just wrote that and not this. I know the rest of that stuff. I know solution number 1, I know solution number 2. So that's what we got to be able to build to. Is this kind of helping you guys out a little bit? This is why I kind of wanted to spend more time on this. So make it a little bit more clear. Does it make more sense? Yeah. So looking at this problem now, we can now write out our equation. And again, I'm not going to solve for this one. I'll show you the next two of how to solve these out, but I just want you guys to be able to identify those. We're going to write it as 0.44 x plus 0.02 times 10 is equal to 0.24 times 10 plus x. Okay, and all you really want to do is use your equation to solve them out. Some of you guys have jumped ahead and solved this out. 0.44x. I'll solve this out for you guys really quick. My calculator can do it pretty fast. Doesn't show all the work, but it gives me the TI 89s are awesome if you guys plan to be a math major. What'd you guys get? I got 11. How many of you guys got 11? Okay, good. So we need 11%. We need 11 ounces fluid ounces. Okay, then if we had 11 ounces at 44%, 2% at 10 ounces, we're going to get a 21% solution at 24. Okay, so that's how we want to be able to identify these and clarify what we're looking at for each specific different type. Okay, so let's look at the next two. I'm going to write these next ones out for you guys, so I'll show you guys how you want to solve them. Okay, so here we go. Let's go ahead and write this out. Try to see what you guys are missing. Try to see what we can identify with. Okay. Now, again, let's see what type of problem this is. Let's see what type of things we're dealing with. Read the question and try to fill in as much information as you possibly can. Okay. So this is a metal mixing problem, so this is mixture problem again. Chemical problems, this is the same thing. How many metal ounces? So our first thing we can always add in is solution number 1 will always be X. I always know that's my guaranteed. We can already put that in. How many ounces of 15% metal? So let's put 15. Must be combined with 3% or 3 ounces of 45%. to form an alloy of 24% nickel. Okay, we're looking at our alloy as our final mixture of that. So if I had no other information to write this in, this is what I should be able to at least get, right? Solution at 15%. How much must be mixed? So we're always going to look for X. Combined with a 3 ounce of 45% to have our final percent of solution being 24. So do we want to add or subtract on this one? Why is it adding for this? Because it has 2 solutions. This is 2 solutions here, right? If we're given 2 solutions, it tells us to always add. So what should that final solution portion on the bottom be? It should be what? 3 plus X. How many is this making a little bit more clear than what we've done this before? Okay, good. Okay, the same situation is going to come up. Okay. I'm going to work this out for you guys this time, just so I can help you guys out a little bit more. We want to be able to write our equation, so I'm going to kind of pull this up and kind of write it out. 0.15x plus 0.45 times 3 is equal to our solution at 0.24, 3 plus x. So this is our equation. I'm going to solve this one out if you guys are still struggling with it. The first thing I want to do is factor out everything that I can, or expand everything. 0.45 times 3 is going to give me plus 1.35. 0.24 times 3 will give me 0.72 plus 0.24x, because I got to use distributive property on that. I'm going to bring my x's to one side. So I'm going to bring my x to this side. So 15.15 minus 0.24. X is going to give me negative 0.09. X. Let's set that equal to the other side. So I'm going to bring the whole number now to this side to the other side. 0.72 subtracting 1.35 is going to give me negative 0.63. We're going to solve this out by dividing. X will be equal to 0.63, 0.09 will give me just 7. Okay, so it's telling us our concentration will be 7 fluid ounces, or 7 ounces of nickel at 50% concentration, plus 3% at 45 will give me 24% solution at 10. Okay. Yes. But not for this one. Not for this one. Not for this one. But if you, for the subtraction one, it is important the way that you write it out. Okay. Always number goes first. That's why I'm always just writing it this way, just to write out or the whole number plus or minus the x value, depending on what we write out. It'll give you the same thing. I know we're so used to seeing x plus something as a factor term, but in this context of the problem, it might just be easier just to write them out with the whole number, just so you don't mess them up and you can get them backwards. Okay. Here we go. Let's try out the other one. So I'm going to clear this, guys. So I apologize. Let's look at the one to the right. So let's see what type of problem this one is again. So we're looking at mixture problems. I'm going to erase that little top right there. So again, read the context of the problem to determine what values you're missing. Again, what's the first thing I can always add in?
X.
The x. X in solution number 1, I can always add that value in. How many pounds of metal containing 15 platinum? So let's say that first one is 15% platinum. Must be combined with 2 pounds of metal containing 35% platinum. So 2 pounds at 35%. Must be formed to contain an alloy of 23% platinum. Okay. So again, I try to fill in all the information that I possibly can for this. I'm given pretty much the solution 1 and solution 2. So what am I going to be doing? Adding. So looking at our bottom portion here, I'm going to have my x and 2, which if I add those two together should give me 2 plus x. 2 plus x. I'm hoping this is a better way to see it, guys. I really hope it is. Because we're going to keep on moving on, and I want to get you guys ready for the test. Okay. I'm going to move this problem up over here so you guys can kind of see it and kind of follow me along. If you guys haven't already done it, we're going to look at 0.15x plus 0.35 at 2 is equal to 0.23 2 plus x 0.15x plus 0.70 0.46 plus 0.23x. I'm going to move everything over in one bit, so 0.15 minus 0.23. So moving my x's over to the left, my whole numbers to the right, 0.46 minus 0.7. You guys get 0.24? The solution. About 0.08. I got 3. Is that what you guys got? Better? Told you it's going to be better. I did a horrible job. I'm sorry. I feel bad. If you need to be a good teacher, man. I don't want to be one that's like, how do you not get it? It's right there. No need to have teachers. I've had teachers in college do that. My crazy college professor would erase as he wrote. Yeah. He was right-handed, so he would round the board, and he would have it long, but he would write, and as he wrote, he would erase. Yeah. And it was on an old school chalkboard. I was freaking out. No, I wasn't even looking at my paper. I was just writing what he wrote, and just kind of I had to redo all my notes later. He was insane. And then he'd go to his office hours and he'd be like, I'd be like, can I get help? He's like, this is easy. Why don't you get it? I'm like, I hooked up with his granddaughter, so I don't feel bad anymore.
Oh, that's awesome.
His granddaughter. Sure did.
That's awesome.
I don't feel bad anymore. We're good. Still remember her name. Her name was Jackie.
That's hilarious.
I was being
Didn't expect that one. Oh, I did not know it was
True story. True story. Okay, fruit and mixture problem. So let's look at these different types of twos. So in this case, you can think of like the solutions being as a brand A, brand B, and the final mixture. So we want to be able to look and identify these out. So these are we almost done with? Are we almost done with the bottom ones? Are these the bottom ones?
Yes.
Okay, cool. Okay, so let's look at these ones. I'm not going to find the solutions for these, but I'll give you guys a setup for this, and I want you guys to find how I got these. But how much of brand A of fruit punch? So let's look at what it's given us. What's the first thing I can always plug in? X. X will always be there. X will always be here. I don't even care about the second one, but I'm just going to throw it in there already. Okay, I already know it's going to be there. Okay. How much of brand A at 14? So that's our first part of this. Brand A at 14 must be mixed with 5 gallons of brand B at 50. So this will be 50% at 5 gallons. To create a mixture containing 26%. So what are we going to use? What type? Add. Please tell me the last one's subtraction, right?
It is.
Okay. Like I have too many adds in here. I should have alternated. Yeah. I mean, once you get it though, you kind of like, you can see it. So I'm happy you guys are getting it, hopefully. Okay. We're going to add our equations up because we have our solutions 1 and 2. We're looking for the third solution. So I'm going to leave it there for you guys to solve out. I'll give you the answers after we're done here. Okay, I'll give you the answers for that. I'm not going to show you guys the work for it. I think you guys should be able to do that. Okay, here we go for the next one. Do me a favor, try out the second one. What does it give us for the second one? What's our equation? At least a setup for it, looking at the second one. Kim asked you to make a 10 liter of fruit punch containing 24%. By mixing together brand A fruit punch, brand B fruit punch, brand A contains 10, brand B contains 45. How much do we need of each? Okay, how much do we need of each? So it tells us, ask you to create 10 liters of fruit punch at 24%. So is this our final solution? You bet it is. So 24% at 10 liters. So what's the maximum liters we can have in here? It's 10, right? So we know that A and B have to both be added together. Brand A is at 10%. Brand B would be at 45. In this case that we're given here, we're given solution number 1 and we're given our final solution. So what should we do in this case? Subtract. Okay? So looking at this, what would that equation look at the bottom one? How would I write that one out? 10 minus x. Okay, we can use these equations to solve out. So go ahead and do those. I'll give you guys the answer key to this real quick. So I'll give you the first one. X will be equal to... Let's check to see if some of you guys are right. 0.14 x plus 0.5 times 5. Did you get 2? I'm just kidding. Got 10. You guys got 10?
Yeah.
Okay, 10. I'm just messing with you. You guys are looking at me like, what did I do wrong? Freaking out. 0.1 x plus 0.45 10 minus x. You all right, bud? We'll see you, bud. What'd you guys get for the last one? Bingo. Bingo. Okay.